While I do this is I would like you to come up with the values that correspond to every input value. So in your mind, you're going to plug in 2. 2 times 2 is 4. 4 plus 1 is 5. Then I'm going to substitute in 3. 2 times 3 is 6. 6 plus 1 is 7. And lastly, 4 times 2 is 8. And 8 plus 1 is 9. So if you had to write down a sentence that's going to describe our answers, we would say something like, when x equals 2, y equals 5. It's just what we've learned. This is in the form y equals mx plus b. But we are now going to switch this up. If you or your partner need to, there are two. So this is the y equals mx plus b form we have. Now I want you with your partner to get the same type of answers. But now this is called function notation. It's the same general equation. Y equals 2x plus 1. F of x equals 2x plus 1. It's called function notation. And we'll talk why we often use this. We still get the same answers. For instance, 2 times 5 is 10, plus 1 is 11. 6 times 2 is 12, plus 1 is 13, and 7 times 2 is 14, plus 1 is 15. But instead of having to write in words what our input and output means, we now have a mathematical statement that does that. So I don't have to write down words. This means in the function f, when I input in 5, I get an output value of 11. If I provided you with the 3 equations that you see on the left-hand side, and I gave you a table of values, and I said, please fill in, what is the outcome here when you input in 2? What's the outcome when you input in 3, and what's the outcome when you plug in 4? You would probably feel really confused because you would not know which equation to use. So in 8th and 9th grade, we generally work with one equation at a time. So if I only showed you this, you'd probably feel confident. Okay, plug in 2. 3 times 2 is 6, plus 4 is 10. Great. But when you have more than one, how do you differentiate which one you're supposed to use? And that's why we name our equations or functions with different letters. So when I see m of 3, what this means is, hey, find the equation that's m, and now we're going to input in 3. Okay, here's m. Let's input in 3. Negative 3 times 3 is negative 9. And now when I add 2 to it, I get negative 7. Let's find function n. Let's input in 3. 3 squared plus 1. Well, 3 squared is 3 times 3. That's 9. 9 plus 1 is 10. Let's find h, and let's input in negative 3. 5 times negative 3 is negative 15. Last part, let's find c. Okay, here's c. Let's input in 2. 2 squared is 4. 4 plus 1 is 5. And lastly, let's find k. Input it in 6. 6 minus 1. A swimming pool was filling with water at a constant rate of 150 gallons per hour. The pool had 75 gallons before a timer was started. I'm going to draw a picture to illustrate this. So this is a very, very simplistic drawing, but this is my pool. It does have some water in, 75 gallons to be exact. We have a hose going in that is dumping at a rate of 150 gallons per hour. Is there a way for us to come up with a linear equation that describes the information that we are given? So whenever we think linear equation, we should think of y equals mx plus b. M will always be our rate, and b will be the initial amount. And if you have forgotten that, you do want to write. All right, our initial amount is 75 gallons, and we are at a rate of 150 gallons per minute. All of this works, but it would be great if we could write this in function notation. So let's think about the 2 things they're talking about. They're talking about water. Now, how is the water measured? Gallons, okay? And what is the rate measured in? The rate is measured in a time of hours. So I'm going to write down here G of H. So the amount of gallons in this pool can be represented by 150 H plus 75. Using a calculator or mental math, I want the person on the left-hand side to calculate this for me. When the timer starts, please listen, when the timer starts, the water will start to gush into this pool at a rate of 150 gallons per hour. If the timer tells me when to stop and measure the water after 4 hours, exactly 4 hours, how much water can I anticipate will be in the pool? So this statement right here says that after 4 hours, the timer stops, and we can assume 675 gallons of water is in the pool. This is a true statement. This statement is not true. We already have 75 gallons in the pool, and if the timer goes for 2 hours, we can assume, well, let's plug in 2. 150 times 2 is 300, but they forgot to add 75. So it really should be G of 2 equals 375. This is a true statement that models this word problem. $4,000 was placed into a savings account on January 1st, 2015. The amount of money can be modeled by the function, where the amount of money in terms of time and years has this equation, where T represents the number of years the money has been in the account. We want to determine how much money is in the account on these particular times. So this is the key. This is my initial. My initial is January 1st, 2015. So I went from January 1st to January 1st, so nothing has changed in terms of the month or date. And this is my initial amount. I'm going to write T equals 0. So most of us can do just mental math like this, but if not, you're going to take the number of years and we're going to subtract it. We're going to subtract it. So 2018 subtract 2015 would be exactly 3 years. Now, in order for me to calculate this, I'm going to come up to my calculator. I'm going to make sure that I first have cleared it. I go to y equals, and I plug in the exact equation that models the amount of money I'll have in the account, assuming I don't take any money out or add to it. And we don't have a t, we have an x. Okay, all of that looks good. Now let's talk about years. Let's see here. Well, this was placed in 2015, and when I look at the time in which I'm going to be asked, so 2015, I need to at least go out 15 years. Let's go out 20 years. So we're not going to have negative years, and time is always going to be in terms of x values. I'm going to graph this, and you're going to see I see nothing on the graph. We just need to adjust this screen. So if I go to zoom, and I go down all the way to zoom fit and press enter, the calculator now will perfectly show the y values so that from x equals 0 to x equals 20 is now going to be visible on the screen. Okay, so let's start here. I'm going to figure out what t equals 3. Remember, we don't have t, we have an x. So t equals 3, I'm going to go second trace value, type in 3, and we can assume that there is a total of $4,384.83 after exactly 3 years. So my account has gone from $4,000 up to this point after exactly 3 years. Here's where it gets confusing. This is my original amount, and so first I'm going to calculate years. I'm going to subtract 220 and 215. So if you're not great with mental math, you're going to plug it in and subtract, and you see we get an answer of 5. 5 is the number of years. Okay, great. But now we have this additional time in months. So January to February is 1 month. Now, a lot of people go, but February is month 2, so I should put a 2. Think of this. January 1st to the beginning of February, only 1 month has gone by. So 1 month has gone by, and there's 12 months in a year. So now to calculate how much money on February 1st, 2020 can be found, I'm going to go second, trace, calculate. Not only 5, I have to add in that additional month. And now we can assume there would be $4,673.65. Same thing here. I'm going to go 2015 to 2023. I take and I subtract them to get an answer of 8, but I have additional months. So January 1st to June 1st, January to February, February to March, March, April, April, May, May, June. So 1, 2, 3, 4, 5. Total of 12 months in a year. Second trace, and I'm going to go 8 plus 5 divided by 12. $5,175.84. Last thing I want you to do is I want you to come up with what should be in this place. Like 5 plus 1 over 12, 8 plus 5 over 12. What should go? The first thing I do is I have to figure out years. So I take whatever year, desired year I'm trying to find, which is 230, and I subtract from the initial year, which is 215. So I have a difference of 15 years, but we have additional months. If this was January 1st as well, I would just have t equals 15. Let's see how many additional months. So January 1st to February 1st to March 1st, April, May 1st, June 1st, July, August, September, and October 1st, the beginning of October. So plus 9 divided by 12. I come over here, second trace value, 15 plus 9 divided by 12 gives me $6,478.82. If I asked you to come up with the exact number of years and days in order for this amount to reach 5,000, remember it starts with 4,000. It starts with 4,000 on January 1st, 2015. We want to go from 4,000 to 5,000. How long does that take? Well, this is in terms of money, and money is our Y value. So I come up here, and instead of going second trace and finding the value, that only works for X's. I come up, I go to the next open Y, and I type in 5,000, and I want to see if I can see where they intersect. I can. Second trace, intersect, I find the exact intersection point, and I'm going to write it down. I'm not going to round. 7.287816. Our X in this case, or T, represents years. So it takes 7 years to get up to 5,000. Now I want to take this partial year and turn it into days. So ask yourself, how many days are there in a year? There's 365. So I'm writing in the decimal, 0.287816 times 365, and the answer is 105, approximately 105. Okay, practicing the second problem here. This time we are investing $3,000 on January 1st, 2021. This equation is going to model how much money is in the account, assuming that we never take money out or add to it. T is in terms of years. So I'm going to Y equals, and you know what, I always think it's best just to restart the calculator. Go to Y equals, I'm typing in 3,000 times 2.05. I'm raising it to the 0.35, and yes, T is years, but when we put it back in here, we're using an X. And it looks like I may have meant to put a decimal and not a negative sign. Let me change that up. 0.35X. Let's go back here again. 0.35X. We got it this time. Okay, so I've got everything that I need. I'm going to go to Windows. Remember, we started in the year 2021 with this, so that's a difference of 3 years. This is a difference of 4 years. This is a difference of 8 years. So I need to go up to at least 8, maybe more. Where X is always our years. We're not going to have negative years, so we can start with 0. I need to go up to at least 8. I'm going to go up to 10, and then I'm going to hit graph. Now, when I look at this, I have the correct number of years I want to see, but I can't see the graph. So if you go to Zoom Fit, it will show us the graph within the X range that we provided by going to Zoom Fit. In order to correctly answer these, you need to know what to plug in for X. The great part about this is we both have January 1st. The difference in years when you subtract is 3. Second, trace, calculate. You should have $63,074.75. 63, 74, 7. B is a little more complicated. Now, if you did not get your calculator to work, I want you to look at your partner's calculator right now so that nobody is falling behind. Okay, March 1st. So it's different in terms of months. I can see the difference in years is 4. 2025 subtract 2021 is a difference of 4. Okay, so it's a difference of 4, but then we have these additional months. January 1st to February 1st is 1 month. February 1st to March 1st is the second month. There are 12 months in the year, so I'm representing it over here in terms of a partial year. I can figure out the year now, 4 plus, in parentheses, 2 divided by 12, and part B should be 8,540. Is this correct? Did I plugged in something wrong, I think. Let's try this again. Value of 4 plus 2 divided by 12. Yep, $8,545 and rounded 99 cents. Lastly, I have a difference in terms of years of 8 years, so this is 8 years. And then again, I have to calculate this partial year with months. January 1st to September 1st, January to February, February to March, March to April, to May to June, to July, July to August, August to September. So this is a total of 8, 8 divided by 12. Second trace value, 8 plus, in parentheses, is the fraction, and we should get $26,471.26. This time, we want to know the exact number of years and days it takes for this account to go from originally 3,000 up to 4,000. So I'm going to go to y equals, that's not our bell, and we're going to type in 4,000. And hit graph. We can see way down here is where they intersect. Okay, second trace intersect, and I'm going to press enter 3 times. 1, 2, 3, and we have 1.145039. So what does this mean? Well, remember our T's or X's are in terms of years. So it takes 1 full year to go from $3,000 to $4,000 if this model accurately describes how the money is earning interest. And now I need to put this into days. So it's just a little bit more, it's just a little bit more than 1 year. I'm going to take this decimal amount, and then I'm going to ask myself how many days are there in a year. There is 365, which gives us 52.93 approximately days. You purchase a car, and you purchase the car in the year 2019. And when you purchase this car, the value is $22,500. And we can see 1 year after purchasing this car, we can see the value each year. We're actually going to make this even easier. We're going to say January 1st, 2019. So 1 year later, January 1st, 2020, January 1st, 2021, and so on. So if you get a little bit confused with years, let's label these years. And we want to know what is the exact number of years, days, hours, minutes, and seconds it takes for the value of this car to go from $22,500 all the way down to $15,000. Okay, well, first of all, we need to be able to create an equation and graph it. So you're going to follow along with me, and I'm going to do this slowly. Start by doing second plus 7, 1, 2. We have data, and I'm telling you that this data is going to relate to a regression model, a linear regression model. What does that mean? Well, let's start by going to stat. Please start by going to stat. If you're in class, on the board in front in green, we're going to follow along with the steps. So please go to edit. Make sure you have a calculator that says L1 followed by L2. If you don't, we're going to want to switch it around. Time, in this case it's years, will always go in L1. You can't flip them around. Time is always going to be in L1. Time is our independent, so 0, 1, 2, and 3. The value of the car depends on the year of the car, how old it is. Now let's go and put in the value of the car for each particular year since you've owned it. Okay, we're going to use this data to generate for us some an equation. It's going to take the average of these points. The more points you have, the more accurate the generated equation is going to be. So here we go. Let's hit stat right now. Find stat. Go to calculate and go down to linear regression model, please. Press enter enough times until you come up with the equation. help your partner really quickly. If they need any assistance, go ahead and help them. Okay, now we need to copy and paste this so that we can see the equation. Please go to y equals. Go to y equals, and we need to copy and paste that in. Directly to your left on the board in black is going to be the directions we use. So after we get to this point, we're going to hit VARs. Find VARs on your calculator, VARs. Then go down to statistics. Go to EQ and press enter. That's how you copy and paste it in. Okay, now we need to adjust. Go to Windows. Our X values are the only thing we're going to adjust. This is year 0, so we don't need negative. There's not going to be negative years. Put a 0 down. And I'm not going to stop at 3 because I may want to know the value of the car well past 3 years. Let's go out to 15 years. Let's pretend we're keeping this car for a long time. Please hit graph. You did not do anything wrong if you don't see your graph. We just need to adjust the range. And it will adjust to match the domain we have set if you go to zoom and go all the way down to zoom fit. Okay, back to the recording here. We are given a value of money. So money in this problem, notice up here, your x's is time, your y is money. We're given an exact y value. So everybody go to y equals and go down to the next open line and let's type in 15,000 and hit graph. Can you see where it crosses? Please find a precise intersection point by going second trace, intersect. And write that number down, please. Do not round. What do we do with this intersection point? What does that even mean? That means if we bought our car on January 1st, 2019, if it depreciates at this rate, 4 years later, a car that was worth $22,500 when I bought it is now down to $15,000. So there's exactly 4 years. And notice it's really close to being 5 years. Well, we want to fill in these places. So this goes back to week 1, what we talked about. On your calculator, please press clear and plug in the decimal amount that remains after our whole number. Now, most students, I felt in week 1, understood, okay, I need to take this decimal and do something with it. But what do I multiply? Everything goes backwards. How many days are there in a year? So take this times 365. The whole number goes into this place. And that makes sense. We had almost 5 years, and we know there's 365 days in a year. Take the remaining decimal amount and write it down. And ask yourself, how many hours are there in one day? 24. So this is 11 full hours. Take the decimal amount. Ask yourself, how many minutes are there in an hour? And lastly,
please transition to lunch B.
Just wait, please. How many seconds are there? There's 42.